Okay, day 18. Let's do this. Boiling boulders. You and the elephants finally reach fresh air. You've emerged near the base of a large volcano that seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and toward the ocean. Bits of lava are still being ejected toward you, so you're sheltering in the cavern exit a little longer. Outside the cave, you see the lava landing in a pond and hear it loudly hissing as it solidifies. Depending on the specific compounds in the lava and the speed at which it cools, it might be forming obsidian. The cooling rate should be based on the surface area of the lava droplets, so you take a quick scan of the droplet as it flies past you, your puzzle input. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result, it approximates the shape of the lava droplet with 1x1x1 cubes on a 3D grid, each given as an XYZ position. Great. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. So if your scan were only two adjacent cubes, like 1, 1, 1 and 2, 1, 1, each cube would have a single side covered and 5 sides exposed, a total surface area of 10 sides. Here's a larger example. In the above example, after counting up all the sides that aren't connected to another cube, the total surface area is 64. What is the surface area of your scanned lava droplet? Okay, that's not too bad. Okay, let's grab this. So for cubies, we're just going to look at a mutable list of, and we'll just call them data class point, which is going to have a val x int, val y int, val z int, and then list of points. And then for the input, this is easy enough. For line in input, each one of these is going to look like this. I mean, these are larger in here, but they're all still numbers, so no big deal. And then we'll just do line.split on commas. And then, easy enough, cubes.add a point of nums 0, or yeah, nums 0, nums 1, nums 2. And then we'll have to do 2n for all these, I guess. Actually, I'll just do them up here. Okay, easy enough. So that gives us our list of points. And then we just want to go through and for each cube, we can just do is for x in list, let's just do val checks is going to be a list of -1, 1. And then for x in checks, so this is going to basically only do the for loop twice, once with -1 and once with 1. And then we need to check the x direction. We also want a list of total, we'll call it total exposed, equals 0. And actually, we can just do all three of these in the same for loop. That'll just be easier. So basically, if the cube that's x minus 1 exists, or does not exist, we're going to increment by 1 and plus 1. And that's, so this is going to be not immediately connected. I'm guessing for part 2, what's going to happen is we're going to look for ones that are not surrounded. It's like this would include, like say if there was a cube inside of a solid spherical shell, the cube inside would still have 6 exposed faces, even though they're not actually exposed. But that is the way the problem statement is written, so I'll do it that way. And then we'll do the same thing for y and z. Okay, and then we just need to return total exposed. See if that works. Check failed. Okay. Well, let's walk through it. Okay, so our first cube is at 2, 2, 2, and then our first check is x minus 1. So we're looking for 1, 2, 2, and 1, 2, 2 exists. It's right there. Oh. That is wrong. We want actually is empty. We want to see if the cube does not exist. Okay, and 3496, let's check our input. That's the right answer. All right, that was quick. Continue to part 2. Something seems off about your calculation. Right, because you have internal stuff. The cooling rate depends on the exterior surface area, but your calculation also included the surface area of air pockets trapped inside the lava droplet. Could not see that coming. Okay. Instead, consider only cube sides that could be reached by water and steam. As the lava droplet tumbles into the pond, the steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. In the larger example above, exactly 1 cube of air is trapped within the lava droplet at 225. So the exterior surface area of a lava droplet is 58. What is the exterior surface area of your scanned lava droplet? Okay, so for part 2, it's not terribly difficult if we think about it kind of in the right way. So a few things that we can't do. It's hard to do it the same way we did before because rocks could be offset and everything, and then you have to try to figure out which pieces are part of the shell and which are not, and the math gets tricky. It's probably still easily doable. It's just, there's so many corner cases, it's hard to keep track of. So then think about things like ray casting or something where we check to see how many are visible from the top and how many are visible from the bottom, so on. But that doesn't really work either because you could have say a crevice where you have to go through it and then it could come back up and everything. You could still make it work, but you'd have to be really careful about how you did everything. It gets, again, tricky. So what I was thinking about is what we really care about is the volume outside of the volume that we care about. So we have our rock, and we really want to know how much stuff is outside of that compared to how much stuff is inside of that. And then from there, we can figure out all our faces. So the way I put it together is basically do the cubes exactly the same way we did in part 1, build out that cube list, no problem. And then I'm going to find a space that covers around it. I just did by 1 each time, but it really doesn't matter. It could be 1,000. It doesn't really matter. But I'm going to make this bigger cube that wholly contains all of our scanned cubes. Then I'm going to fill that void up, basically. So I'm going to add a point for every part of that void. Then I'm going to remove everything that's in that void that is a scanned cube. So places that there is a rock, we're going to take it out. And then that means we're going to think about a cube of void, and then we're going to have some areas that are missing. And then we have there might be some rocks inside and other little areas that are missing again inside of it. So we need to remove the interior parts. Or the easiest way is really to just figure out what the exterior parts are. So I'm going to just start with a breadth first search from a point that I know is on the outside. I just did the first one that has a minimum X. It doesn't really matter. We just want to make sure we have one of the points on the outside of the shell. And then I said breadth first search using a queue, basically add that to the queue, mark it as visited. And then we wanted to run through and do the checks the same way we did in part 1, except in part 1 we wanted to see where cubes did not have a neighbor, and here we want to find pieces that do have a neighbor. So we want to find void that is next to void, and it doesn't matter if we visited it or not, because next time through, if we're not visited, or if we've already visited, we're just going to skip all these checks. And then basically we're just going to add all of them into each other. So the next part is now that gives us a shell, and we need to find what parts of that shell touch rocks that we have already added. So basically I put for v and void.filter visited, so this is going to ignore the areas that we can't see from the outside. And then 4 seeing cubes. So every pair of void cube and every pair of rock cube, we're going to see if they touch. So if they touch on the X face, if they touch on the Y face, if they touch on the Z face, if they touch on any of those faces, then we're going to count exposed. Again, this is probably not the most efficient way to do this, but it's a very small number of cubes for both of them. It's going to go through real quick. And at that point, we know basically, again, how many faces are basically touchable by the outside. And so it runs pretty quick, just 300 milliseconds. So again, good enough. Anyway, so only 1 week left, and I will see you guys tomorrow.